Okay? All right. Let's zero in here. All right? And what we just did with that pizza party, guys, shh. George, do you... Okay, hold on. So, take your pen, pencil, whatever it is you have, and draw a box around this equation right here. Because this is our inverse variation equation. Like with our pizza party, that was y equals 120 divided by x, right? That's our inverse variation model. So K is just whatever our total is. If we're at a restaurant, it's the total bill for the restaurant. It's the total number of whatever we have divided by the number of pieces. Okay? And we have to be able to do a couple things with something that's modeled this way. One of the things we have to be able to do is look at a table and decide if it represents this, and if it does, write the equation. Okay? And you all, without really knowing what you were doing, you did that already. All these tables are inverse variation tables. So like, I will look at this one, for instance. Okay? Looking at that one, what is the K here? In our pizza party situation, what was the K value, the total? It was the 120, right? Okay. So what do you notice about the numbers in this table? About the numbers on the left column and the right column? Like, look at the 60 and the 2, and the 40 and the 3, and the 20 and the 6. What do you notice about those?
It's all 20 below.
Okay.
It's counting by twos.
It's counting by twos. Okay, well, okay, don't look so much at the pattern between these numbers. I want you to look at the relationship between each row. So like 60 and 2, 40 and 3, 20 and 6.
It's like 140.
Okay, the less there are, the more pizza slices, okay, and vice versa. Like if I added a table for 10 here, like if I had 10 party goers, what would be the number of pizza slices? 12. So party goers times the number of pizza slices each time equals how much? The total, 120, right? So the K, the constant, can be seen in the table. If I multiply the X and the Y together, I get the same amount. 60 times 2 is 120. 40 times 3 is 120. Let's look at somebody else's. Is that true here? If you multiply X and Y, do you get 120? Yeah. So that can be the way that we find the total. If we don't know the total, or the K, we find it by multiplying. Okay, so if I look at another table and I want to know, determine if the relationships in the table represent an inverse variation, what I'm going to do is I'm going to multiply these, the X and the Y's together, and if I get the same number, then I have inverse variation. Okay, so like if I multiply 0.2 times 8, I get 1.6. And if I multiply 0.5 times 20, I get 10. So what does that mean about this table? This is not inverse variation. So here I would put X times Y is not constant. So this is not inverse variation. Okay? All right, let's look at the next table. Let's see if this one is. Okay, so all you do is multiply X times Y. Because if I look, you know, right to the left of the equation that I put a box around, that tells us X times Y is equal to K. So 0.2 times 40 is 8. 0.5 times 16 is 8. 1 times 8 is 8. And 2 times 4 is 8. Okay, so is this inverse variation? Yes, because in this case, xy equaled 8, so this is inverse variation. Okay, and then it's saying if so if it is inverse variation, write the equation. So what equation do I write? the equation that I boxed, because that is the equation for inverse variation. So to get y, that would be equal to our k divided by x. And what is our k? 8. Because to get all of the values of y, I would divide these numbers, or I would divide 8 by these numbers. Does that make sense? All right, you guys take a second and you try this third table, okay? So it's the same, it's just on its side instead of up and down. So decide if it's inverse variation, and if it is, give the equation. Just take a minute to do that. Okay, what do you think? Is this inverse variation? Well, when you multiply x, y, 6.5 times 8 was 52, 13 times 4 is 52, 104 times 0.5 is 52. We got the same thing each time. So that would be yes, right? Because x times y was constant and it was 52. So because of that, this is inverse variation. And our equation would be y equals k divided by x. And what is our k? 52. So it would be 52 over x. Okay? So one thing we have to be able to do is look at a table and decide if it's inverse variation or not. And if it is, we write the equation. And to tell, we multiply x times y. Okay? Okay, so same scenario a little bit, but let's look at a specific point. So this says, suppose x and y varies inversely. So that's telling us that we have this situation. We don't have to find out if we do. We absolutely do. And x equals 2 when y equals -3. What function models the inverse variation? So it wants us to write an equation like we put in the box. And the thing that we need to know is what? What piece of this do we need to know? K, right? We need to know K. Well, did they give us K? No. They gave us an X and a Y. But that's enough information to find K, right? How do we find K if we know X and Y? Just multiply them. That's all we do. So we find K, and the way we do that is we multiply our X times our Y. So K is equal to X times Y. So our K is going to equal our X, which is 2, times our Y, which is -3, and that gives us what? -6. So K is -6. When it says what function, that's why I had you put this in a box, because some people think that this one's the function. That's not the function. It's this one. Okay? So Y equals our K, which is what? -6 divided by x. That would be our function. I'll put that in a box because that's the answer. Okay? Then typically after we find the function, we're asked another question, like to find some value. Okay? So what is y when x is -5? All you do is you plug this number into your equation. That's it. So we just plug this in. So plug in. Okay? So y equals -6 divided by -5. And what is negative 6 divided by negative 5? Put that right in your calculator. It is 1.2. Okay? How do we feel about that? This isn't that bad, really. Okay? So let's look at we did a pizza party, and now let's look at another one, a park cleanup project. So your math class has decided to pick up litter each weekend in a local park. Did y'all know that's what we're doing now? Yep. I signed you all up this weekend. Carroll Fox Park, picking up litter. Be there. Just kidding. But you should do that because it's a good thing. Each week there is approximately the same amount of litter because people are dumb and they keep littering. The table shows the number of students who worked each of the first 4 weeks of the project and the time needed for pickup. Let's see if this makes sense. 3 students showed up and it took them 85 minutes to clean up. And then by the 4th week, 17 students showed up and it took them 15 minutes. Does that make sense? Well, yeah, the more students that show up, you can get the work done quicker, right? I mean, right? That makes sense. So it seems like this should be inverse variation, right? As one thing goes up, the other goes down. So what function models the data? So again, to know that, we have to know the what? K. And to figure out K, we're going to multiply X times Y. But we don't have X and Y. We have N and T. So N is like our X and T is like our Y.
All of them are 255 except for 12 times.
Yeah, so sometimes that happens because, I mean, real world data, right? Sometimes we don't have exactly the same thing. So like, let me make sure I'm typing this correctly. All of them are 255 except for 12 times 21. We're just a little bit off. But you know what? It's so close that we're going to go ahead and say that K is equal to 255. Okay? So what function models our data? Well, instead of Y, we use T because that's just what it says, right? So the time it takes to clean up is equal to 255 over, instead of X, we use N. Okay? How many students should there be to complete the project in at most 30 minutes each week? Okay, so I got to know, what do I plug in that 30 minutes? 30 minutes, is that T or is that N? N is the number of students, T is the time in minutes. This is T. Okay, so we're going to plug in 30. So 30 equals 255 divided by N. How do you solve that? Do you know how to solve this? I mean, I'm gonna make an assumption here. Like back to middle school, remember proportions? See how that's a fraction, but this one isn't? And I give that a 1. Cross multiply. 255 equals 30N. You just divide. Y'all remember that? Like I'm reaching way far back, like middle school. Okay. So divide by 30. That's 255 divided by 30. N equals 8.5. But I can't have half of a person show up. Right?
Just say 9.
I can either say 8 or I can say 9. If 8 people show up, it's going to take longer than 30 minutes, right? So I need that 9th person. So we're going to say 9 students. So like, look guys, if we want to be out of there in a half hour, I need 9 of you to show up. If less...
That 8th person breaks their back.
Yeah. I mean, we're assuming these are 9, like, able-bodied, motivated people, right? If you see someone not doing their fair share, you let them know. Okay, let's end with an SAT question. SAT question. Because, you know, this stuff is on SAT, but it's never presented this way, right? All right, so it says the pair of values is from an inverse variation. Find the missing value. So these are points off of a table that is inverse variation. Find the missing value. It could. How would we go about figuring this out? Exactly. We have to find k. That's like the theme, right? Find k. And we find k by taking x times y. And I have an x and a y to use, right? So our k is equal to negative 4 times 1, which is negative 4, right? So our equation is y equals negative 4 over x, right? That's the function. Now, how can I use that to figure out this missing value, y? Just plug in the 6 for x, right? So y is equal to negative 4 divided by 6, which is a fraction. We can just simplify it, right? Which is negative 2/3. So our missing value would be negative 2/3. Kind of asked in a sneaky kind of way here, okay?